Hey Patrick,
Hello.
how are you?
Great. And I have been watching already some presentations before.
Oh, that's great.
Yeah. And I know there are also like some familiar faces so during the day. So that's great as well.
Oh, nice, nice, and great that you joined even earlier. And and first of all, thanks that joined our event, and it's a pleasure to have you together with us today. And you will share some insights from building intelligent, truly intelligent applications. Yeah, you'll show us some examples how to make Java app more smart and intelligent, especially because it's still a hot topic, AI and all these LLMs. How we can combine all of that together? Maybe it's just really including a dependency and that's it. Curious to hear.
Well, as my talk is about Spring and Spring Boot, Spring AI and Spring Boot, definitely, yeah, it might be just a starter. But of course, also over the time, I have realized that if you're building such applications, you will have some challenges, and I hope I can point some of them out as well, like during my presentation. Because sometimes it's just easier to use something which is provided by the big ones like Google or Microsoft or whatever than actually like building everything on your own. But
Hmm.
maybe you want to do it still, right? And that's why
Let's hear.
this is the presentation. Yes, great.
Yeah, cool. Then go ahead and let's go.
So, yes, my talk is about making applications more intelligent, or basically like adding a large language model or maybe even multiple to your Spring application. And as you probably know, Spring is like one of the big frameworks we are using for Java-based applications. So Spring actually also came out up with a library or like an integration layer to use like LLMs. So let's just jump into my presentation. And the first part is just like, who am I? So I'm Patrick. I'm basically like from Switzerland, and I'm working in the Spring space since a very long time. So I touched probably Spring the first time around 2007, and since then I'm doing quite a lot from training, architecture, working with teams, and so on and so forth. And I'm also heavily involved in the development community, like doing presentations right now, running as well events, and doing many other things. Yeah. So that's about me. I wanted to tell you first, and this should be like more like a disclaimer saying, hey, we are just talking about like how to integrate Spring AI and LLMs into your applications, and it's not actually like discussing things like prompt engineering, fine tuning, and other things, right? We might touch certain topics which are important maybe to like where do you get an idea what kind of models you can choose, but I cannot definitely like tell you like what you should actually use for your specific application, right? And then other things like sustainability, social impact, and other things, that's another story actually, like which needs to be discussed somewhere else. I'm definitely going to show several examples so you can get an idea like how simple it is to like integrate different LLMs. So probably you know what artificial intelligence is because we have been doing or using it already like for 2 or 3 years, and they're like big tools out there. And artificial intelligence is basically like a huge area where also like machine learning and deep learning are part of it. And it's more like the broader meaning of like what we are using these days. And all these tools usually we use like ChatGPT or Gemini or others, they are just basically like part or a small part of it, which is called like generative AI, and which has also like a combination with some LLMs. You see there in the drawing, there is kind of like this sweet spot. And you could even say actually like what we're using these days was like after probably like 50 years of research, like the first time someone can or companies can monetize actually like what they have been researching for such a long time, and actually like we get applications for this kind of technology. So just talking about a few examples, well, you know, the internet is always about cats, right? And I mean, you can generate content like this, generating images of cats if you want to. And I would even say like this is a really beautiful one. I mean, I was writing a prompt for that, and you might see some flaws actually in the picture, but if you look a little bit from away, you will actually like realize, oh, that's just like nice picture, and I probably would even hang it on my wall. So it's colorful, it's like neat, you know. We don't have finger problems because of it's a cat and stuff like that. But this is kind of a joke, right? Content generation is maybe not that most important part, how we should use these days these large language models. Just to give you an idea, like how you could leverage this inside your company. Think of use cases actually like where you would build queries with natural language. Instead of using like something like SQL and just like one data store, you might use like natural language to basically like do things or check things like emails, complaint logs, tickets, and so on and so forth. And you would get an overall understanding of like why, for example, the user did close the account. So if you have this data, you can aggregate that, and you can actually like query unstructured data in a very natural way. Of course, and that's probably like what you're doing also quite a lot, and even like my email client does it. It's going to aggregate and transform actually like the text, right? So that means like you get, for example, in your Gmail app, some aggregation of the email thread, for example, things get summarized. You can extract bullet points. You could even like say change the way it's written, so it's like maybe more positive, more neutral, you know, these kind of things, or even like remove like sensitive data. Or you might even translate very easily with a large language model text these days. So translation engines started to be built up on top of these LLMs as well. And you will realize the ones which are still using probably like the older technologies, they're maybe not performing that well like the new ones. Right. And there are more examples like manipulate data. And for example, there could be even could even be something like you're calling code, right? Which does something. Like in this case, reactivate a customer account and notify them by email. Or other things like you are having like business rules specified, which are executed from time to time, and then actually like you do something on top of that. And the last example we probably know all, you can even like generate some code. You can even like create from unstructured data, structured data, stuff like that. These are like very typical use cases, right? And it doesn't have to be always a chatbot, as we see like in most of the examples. So for me to understand this, it's very important to get the idea that not all the time an LLM needs like a user doing something. As you can imagine, like when you automate things, you might have like time triggers, you might have event triggers, or you might just like have some buttons which needs to be pressed by someone, right? And I mean, that's just like very important to understand. Like it's not always a user which needs to interact with your model. So it could be also like that you just like have some entry stage, and then afterwards you're even like running a whole workflow with multiple ping pongs between the models, right? And that's actually like something which is now also often done in applications, that it's not just like one prompt and then you get the answer back and that's done, right? So workflows could be also like a topic here. So like looking at the perspective actually like of like what we need to do to like use this kind of thing, it's basically like we have on the right side the generative AI, the LLMs. We have on the left side actually like your company data. And as we know, the models, they're basically like trained on public knowledge to a certain date, right? And therefore, in a company perspective, it might be interesting to have like up-to-date data, current data, actually like even part of the prompt or being available to the prompt, you know, so that you can also like answer things like what will be the weather tomorrow, what do I have to wear, that it's actually like accurate, and so on, right? So like real-time information or nearly real-time information needs to be like presented basically like to the models. So in the end, actually, like we will find out these LLMs from an enterprise application perspective, it's nothing else than just like an integration problem we have been solving in the past already many times, because we are just integrating with a REST API, and that's basically it, right? And that's very important. It's very important that like if you do something, and I think actually like the ones who came up with these LLMs, they made it accessible to everyone in a very simple way. And that's like why they were putting in front of it a REST API. So that means like you're not restricting your models to like Python or C developers, but the whole world can actually like use it. If you're using PHP, for example, or Java, or whatever you want, basically like everyone can do it, and you can even call it from curl, right? So therefore, that was basically like one of the best ideas they had, to put something in front which makes it accessible for everyone, and that's basically just a REST API. So just that you see like what will go behind the scenes when you use like frameworks which abstract things for you. It's definitely really like HTTP calls which are happening, and I guess you know that. But you also will see like there is some information actually like going on here. And this is just an example how it could actually like look like. And you see basically like two parts where I'm injecting here the key basically, and also the prompt. And you might even have like certain roles for different parts of the message. I'm not going to execute that, but just like keep in mind the response will contain of like the answer, of course. But then on the other hand, we will also have like some statistical information, for example, like how many tokens were burned and other things actually, right? So it's a proper JSON document which is coming back, which the library we are going to integrate with needs to parse. So thinking or talking about models, actually, like there are plenty of models out there. And for me, the important thing actually like you need to understand is, if you use a tool like ChatGPT, just as an example, ChatGPT is for me like just a front end to like several different models, because OpenAI provides you through ChatGPT things like models to deal with text, of course. You have like image generation models, you have text to voice model or voice to text models, and you even have like embedding models. When you upload documents, you kind of have a RAG in your ChatGPT to basically like extract the information needed for the prompt to like answer your questions, right? So there are plenty of models out there. Certain models are even specialized and only doing like one thing. And then you have like tools like ChatGPT which integrate on top basically like with all the different models, right? And there are like many ways how to do things, as you see on the drawing. So the thing here basically is like we know that if we are maybe not precise enough or so, then actually like it might hallucinate, right? And that's why we have the colorful picture here with the clouds and so on. And that's definitely like the challenge. So to make sure that there is enough context to basically like create a proper result or a proper answer out of it. And this is kind of a challenge basically, just because I think that these models, if they're like blind spots, they just fill the space. So they behave like our brain, because like if we do not know about something, or if we cannot fill the gaps, then our brain doesn't feel well, and it tries just to come up with some maybe crazy ideas, and just like fills these gaps, right? And large language models are very similar actually like to the human brain. So the question is actually now, when you're going to use large language models, is the question which ones should you use, or which one should you use? And there is actually like a very good idea out there, which people came up with and they said like, let's like rank those models. And there are like leaderboards out there, and actually also have on my presentation the links, you can directly jump there. You could see on this leaderboard basically comparison between the different leaderboards because of like the context window size. So that's the tokens you can actually like put in and work on the information provided, right? You see like things regarding the prices, for example, and a few other things. So they can be ranked, and maybe you want to go for a cheaper model than a more expensive model, depending on your use case. There are other leaderboards out there which are also specialized for certain topics, right? If you think of like you want to have a model which is maybe specialized in doing math, then a general purpose model like OpenAI models or Claude models are maybe not the ones you want. But we see basically these days that like models are converging to these general purpose models, that most of them basically like provide you good answers for almost every task. But there are also like some specialized out there, and like these vibe checks are basically like community ratings, so you get an idea which model performs better for a certain task. And you could even say like almost every week, this kind of like lists are changing because new models out there, new version of models are out there, and obviously also the rating gets updated because of the experience of the users. And then actually like there is this LLM leaderboard where people even can compare it, and you can actually like play around and have like a battle between multiple models, so you see like what is the different results. And that's actually also quite a cool idea, so that people are writing prompt, comparing it with the different models, and then you can basically like vote for them. I just want to show you here some examples how you can get a gut feeling what kind of model might be good for you and which one you want to integrate. So let's talk about a few advanced AI concepts, right? We have to be aware of that the model actually like does not learn. There needs to be a release, it needs to be trained newly, right? And that's very important. So that means like if we want to deal with up-to-date data, we always need to provide it. And that means like we have also to check like what's the current model. And maybe if you don't want to have like a breaking application or a broken application, you want probably also like to pin down a certain version of a model. And usually in the documentation, you will find this kind of like information from when was the model actually released. And that's really important because like the knowledge, the public knowledge is from a certain date, right? When they started doing the training. Now the question is actually like, how do I add my own company data, which maybe is not even in the internet, not even public, right? And that's like, there are like certain approaches which we can actually use to bring in this like real time or almost real time information. And yeah, and we have to deal kind of with the limitations we have. So the thing regarding bring your data is actually like, yes, we cannot train our modules because that would be probably too expensive for most of the companies. Fine tuning, it's still possible. So you get like your own deployment and you could still like fine tune the model, like maybe adding like 2 more layers on top of it and so on. But that needs already quite a lot of knowledge. So I would say like for most of the software engineers, and if you just like start prototyping a new application, it's maybe the best idea just to like enrich the prompt in different ways. And that's like the things regarding prompt stuffing, RAG, tool calling, or even these days like MCP servers, which are very similar to the tool calling approach. Now let's dive into the topic regarding Java and AI, because like we are talking at the Java conference, and for us it would be interesting like what's out there, and of course in the Java ecosystem also like big enterprises want to use actually like AI models now these days for small tasks. So everyone kind of starts experimenting with those things. In the Java space, there are like two I would say, libraries out there which can be properly used for this. It's like the Spring AI, so this is like an independent implementation, basically like from people from the Spring team and the community. And you have on the other hand LangChain4J, which also got like quite a bit of support through Quarkus basically, because LangChain4J is kind of like the preferred way to integrate models from the Quarkus ecosystem. Microsoft has like another thing which is called semantic kernel, and semantic kernel comes also like with different flavors, with different implementations, and it's also just like an abstraction on top of the REST APIs, basically like of these models, right? Good. Now the question is actually like, since we are in the Java space and the two big projects are Spring AI and LangChain4J, the question is actually like, which one should we use? And I found like this nice Reddit post where a person actually was asking, which one should I use? Which one is better? Which one has more capabilities and stuff like that? And the answer to that one I found awesome, because the guy said basically, does it really matter? Both are just API wrappers because it's REST APIs, and actually like it's more important which model we are using, because like this makes the huge difference, right? So that's actually like the idea. That's actually like what we should be aware of. So now diving into the Spring AI part, of course, is like very interesting for us because it makes our life simpler with all these ideas, how a Spring project is built, right? So you would get like features automatically if you use Spring Boot, like for example, observability, just like built in, because like all the Spring libraries these days, when you add an actuator to your Spring Boot app, actually have automatically built-in observability. Spring also provides you different things like integration for vector databases, like chat memory, tool calling, MCP server integration, and other things. But just like from the perspective how it should be done within like a Spring project with all these mental ideas, like how Spring does things, and also like how Spring usually creates abstractions so that we could replace things quite easily, right? So Spring AI, you could say, is very similar from the age like LangChain4J. They basically started around the same time with the first implementations, and they are like all of them are like influenced by the Python libraries out there. And of course, I mean, they are not copying them. They are not like just like a translation or so. They are just like they started from scratch, but they got really inspired, and now they are like doing other things. And I'm sure there is of course people like watching the competition and see like what they should as well like integrate, because maybe it was just a nice idea. So Spring AI is currently based on Spring Framework, the current version, and as well on Spring Boot. So getting started is super easy. It's basically like as you would do with any project from Spring Cloud or from Spring Data. You're just pulling in the BOM file basically, like for doing the version management, and you work with that, and then you just go and add starters, right? So if you do the skeleton project from Start Spring IO, it will be done for you automatically. Basically, the same applies for Gradle, right? So this is just like my example because I prefer for presentation, Maven because it's just like simpler to understand. Then actually like you would pull in a starter, and the starter are named with a specific pattern. You see here Spring AI starter model OpenAI. But if you would use another one, like for example Anthropic Claude or like some others, you would be able just like to replace the starter. And this is kind of the abstraction you get actually like from Spring or from Spring AI, with the idea that you just can replace a few things and maybe adjust the properties. As you also see below, actually, like we would use properties, they're also like in a certain fashion. And of course, we are not checking in the API keys for the LLM, right? So that's why I'm using an environment variable, which will be automatically injected here. Good. So the first thing actually like we are talking about is chatting, of course. And when we are creating a chat or using like a chat bot, basically, then we start doing like prompts. Now in Java, or especially in Spring AI, they had the idea to use a library which is called the string templating engine. And it's an open source library which allows you to do something similar like what you would do like with prepared statements in SQL, right? Where you had like placeholder which can be replaced, as you can see in the example, like here with the genre, and then actually like you create out of this template a new string which is feeded into the chat client. The chat client actually like can be called, and the call basically like gives you the answer, and with dot content we are just like extracting now from the JSON document which is coming just the answer. In the example below, you see actually like that we are going for a chat response. And the idea of a chat response is something similar like you would probably know from response entity, right? Where you have kind of the header and the footer part in there. And that's like what we see here as well. We can go and extract just like the certain areas of the JSON document, which is designed or defined behind the scenes, right? So we can like read more information than just like the answer part of the statement. Great. And the chat client basically like is not injected by the starter by default. You would get like with any other client in Spring like a builder first, and the builder needs to be configured. You can't just like do something like I did. You could specify a system prompt which can be overridden later, or you just call like chat client builder.build and you create out of that the chat client. It's very important to understand that Spring Boot, for example, for REST clients, web clients, and so on, or the templates basically have builders because of the observability features, which need to inject some interceptors to make sure that, for example, some tracing IDs and so on are passed to the system you're calling, right? So that's why that's important. We are just like working on the builder, and that means like we need to call builder.build to create the client, right? You see also then the client itself has a Fluent API where we can easily like create our prompt, do the call, extract things, and you can also imagine this is quite of a normal thing these days, because like many client APIs like are following these days now this kind of like Fluent API approach. The last example is actually like quite a nice idea, because there, instead of just extracting just a string, I'm saying, hey, the result which is coming back, map that to a particular class or a record. In this case, it's I know I did it as a record. It's working. So actually, like my prompt gets manipulated. That actually with JSON, the result can be like mapped on a Java class, and from there I just can like start using now my Java object so that I do not need to like do the mapping myself. Right. So you could say Spring AI is heavily influenced by the model from OpenAI. We have request response, of course, but then actually like what the parameters are on the API, like the model you are selecting, the messages you pass, it's like heavily influenced by how the API from OpenAI looks like, right? As a result, you would get back the model which is answering, maybe even with a specific version number. So you say like it's GPT like 4.0, and then you get even like the model back with a timestamp at the end. So you know like what model was answering. You see then also like a list of choices, a finishing reason, some statistic information like usage of tokens, and so on and so forth. Good. So now let's have a look shortly. Before we dive into the next topic, I will like present you some small demo so we can have a look at this, how this looks like. And therefore, I'm just pulling up Visual Studio Code where I have like some examples available, and we just like see like what's going on there. And of course, I will provide your link at the end with the repository. You can play on your own if you have these keys available, right? So let's go for the first example. The first example is just like the OpenAI chat basically example, which is quite simple, and it just should actually like get like my client builder. I created the chat client, and then I'm executing here my prompt, right? As we said before, the answer is basically like a enum, right? No, not an enum, a record, sorry, with two fields like prompt and response, and basically like it gets added here. So we tell the client the answer which is coming back needs to be mapped on that particular object. Regarding the configuration, what I used here is I just like did things like specifying basically like the configuration for OpenAI. I'm choosing a model. I'm like making things more visible for you so we can see something in the logs and better understand what's going on, right? I turned off the Spring Boot banner basically, and I said it's not a web application, that because like there is no need to like do something like starting up a Tomcat or whatever, right? So that's actually it. Anyhow, let's jump into the application, and I'm just going to run it here. Yes. And we will actually like see our Spring Boot application here just started regularly, and then actually like it started here, and then actually like it was writing my prompt to the API. And interestingly, the thing is, to the prompt, something actually got added. And you see that below here that it said, your answer should be in JSON format. Please use that RFC for a JSON specification to make sure that we get like proper JSON. And do not use markdown code blocks and so on, because actually like things get harder to parse, right? So that's why things need to be removed. It also provides us actually like the JSON schema, where we said like prompt and response will be the fields of the object we are like mapping the whole thing against, right? And that's like what you see here. So prompt and response. And if now the execution happens, the model might realize, hey, I have the prompt and maybe can add the prompt into the prompt field, and I have a response field, so probably the answer needs to go there, right? So the model tries now to do the matching. Maybe it works, maybe not. It's not always guaranteed, right? Because we did not give enough hints for that. I could have specified it even more if it's not working, right? And then actually like we see the answer coming back, right? And at the end I'm printing everything here, where I'm saying here it should share me a tip, basically like how can I improve in general like Java code, and it gives me like an idea like using the final keyword for parameters and local variables to signal immutability, right? So that could be a thing. So we have kind of like the prompt in front and like the answer at the back. And it was before just a regular Java object. Good. So jumping to the next topic is actually like we can also work with images. It doesn't have to be always text. And therefore, the question would be maybe like, can we interpret images? And you probably know this is just like the weather forecast on on Google. If you search like for a city and say like, tell me the weather there. And the question would be if I provide basically like an image, if it can interpret it. And we know that ChatGPT or OpenAI has a model which can do basically like do some OCR on images we upload, and then basically like we get answers to that, right? And this is basically like my next example I'm going to show. So here, and this is actually like the image example, which in our case, I'm just closing things again, creates a chat client. I'm adding now to the prompt an image here, as you can see. I call it and I get the answer, right? And the answer or the question is actually like, what will be the weather like on Tuesday, which is part of the image, right? And by executing this, you would get the proper answer to that. So you see also like there was the image uploaded, basically like in the base 64 string, which is part of the request, right? And then the response actually like is coming back. To be honest here, I probably have to do a pull request because it's actually not printing like what the answer is in JSON format. Only like that it's this class here. And the answer then, which is like the final answer, like logged from the application, is actually like here where it says like the weather is to be expected 22 degrees and so on with like light rain and stuff like that. Good. So let's jump to the next example then. So this would be like the question like dealing with audio, for example, because you can also deal with audio. And that's quite neat because like you can basically like transcribe anything, right? You just provide like an audio and you're like specifying then or extracting the text, right? And so actually like the tool needs to decipher what was spoken in the text. And I can show you that actually as well in an example, and I find it quite interesting. So let's use the one where I specified the audio transcription example. And this is basically like the thing. I just like close things down here so you can see it. I'm injecting basically a MP3 file, and the MP3 file gets then passed as a audio transcription prompt, and we just like try to convert that basically like to the text. Now let's run this, and this is slightly different because I did it as a web application. So it's simpler for me to like prove you some audio, right? So you can hear it, how it sounds and stuff like that. And we just like do it here in the browser. Localhost 8080. And let's go for the original one. So like that would be, you should hear now something, which is kind of an audiobook, and it's in German, basically. So you hear somebody talking actually, and I just have like 42 seconds in the MP3 file, so it doesn't take like a very long time. And actually like when I'm going to call here a endpoint, which is called transcription, it's going to transcribe these 42 seconds into text, right? So the example shows now basically in the backend that the MP3 gets uploaded and it's going to translate things. But of course it does mistakes because like our detective is not called Meloni, but he's called Maloney, and that's just like wrong. So sometimes even these models do wrong things. Maybe you want to have a translation not in German because the audio was in German, but maybe you want to have it in English. And maybe you want to like do even other things, and that's what I do right now. So I used like some provider options, like specifying the format, how it should like translate it to like English, right? So basically like German audio to English text with the timestamps and so on, right? And that can be done actually like in the IDE. When I said like we use these provider options, we said like I want to have it in English. I have a prompt added. So the prompt actually here is just a hint that the detective of the audiobook is actually like called the right way. So I gave a hint with like the spelling of the name, which is kind of weird because it's pronounced English, but the whole audiobook is German. So that's why the model was not proper doing it, right? And I just gave it a hint basically. I said don't be too much creative here. And I also said, for example, like use that format here for the transcription response. So that's like how I could use that. Of course, now let's get a step further. We could even say like we could use text and like make some audio out of that. And that's possible as well, actually, like if you are using a speech model. And the speech model takes a text, which is here basically like injected, and it's the same thing. So it's just like taking the text basically like which is injected, and then it's executing some audio. And as you can see, also just like for the purpose of like demo, I just like return it in the controller as a streaming format so we can get the player and we just can play it, right? So we can do that right now. Oops, that was the wrong one, I guess. I pressed the wrong button, sorry for that. We'll just like start the application now. Should be the right one, the speech one, yes. And actually like we just do here speech. So you can hear now actually like that the text I'm using is now spoken by another person. There is no music and stuff like that. It takes a while now. And as you can hear, it's even translated to English. Right. And probably we all know that like having slow red text is like boring, right? We want to like improve it maybe, and that means like we could even play it faster, right? So there are options you can say or provide, and also with the prompt that you could say like, let's run it like 30% faster. Philip Maloney's hair-raising cases. Hair-raising cases of Philip. And now you realize actually it's getting worse, right, with the quality. But I was also able to change the voice. So OpenAI has basically like a few voices you can choose. And like in the example here with the provider options, I was selecting a specific voice here. And as you can see, when I use auto completion, you can see like the voices they have implemented actually, and you can choose from them. So you cannot use like your voice, but you can use like one of the default ones here, right? Good. So that's another nice thing. Great. Let's jump back to the presentation. So you see also like in the presentation like some parameters, the one which was a transcription model, the other one actually like for the speech model. And probably you have also realized in this case we don't work with a client. So the thing is actually like when you use Spring Boot, the chat client or like an image client gets injected, and the clients are like the highest level of abstraction you can get. If you want to have like two different models used at the same time, or even different model providers used at the same time in your Spring Boot application, you would have to configure like the model itself. So the client is on top, basically like the underlying abstraction is like the model implementation, which we're just using here right now. And then you would actually have the REST API below, like the REST client from Spring, right? These are actually like the three levels. And sometimes for certain models, you need to use the model implementation, and on others, you can actually use the one on the higher level, the client one. Of course, Spring also supports you like with RAG, so Retrieval Augmented Generation, so which is basically like the idea where you add your own data, your own documents, or at least like even some chunks of it, right? And the idea to that is always like if your data is more up to date than like what the model is trained on, then basically like we are shipping this information in the prompt, right? And that means like you can basically like have a higher priority with the data you send over the one which is in the model. And for example, this is just an idea like for something, if you ask for it, right? And then actually like you go and say, no, in the prompt, I say these and these are my sports. And then you ask like how many sports were there, but you said like which ones were there, right? And then the model is counting for you. And the difference now is quite big because we had by default like 45 different sports. And if you say like these are the ones, right, it tells you 12. So your data has precedence over the training data. And that's why it's important actually like to stuff your prompt with things. And that's like how we do it like with extensive prompts. So or with RAG, for example, we are just adding context to the prompt basically. And we burn token with this approach, of course, because your prompt just gets way bigger. And yeah, that's just the idea of like stuffing the prompt, just like adding context, adding your prompt basically like to it, and then it will work on this plus the general knowledge. With RAG, it's like this, that your data is usually stored in a vector store, or your documents are stored in a vector store, and we do something like similarity search on a vector store, and basically like things get pulled in, right? So that means like your data, your prompt gets enriched with chunks of the documents in the vector store. And then you have your augmented prompt, and the answer is sent from that one. So vector store are multi-dimensional databases basically, and your chunks will be stored somewhere. And as I said before, there will be like some similarity search executed. Interesting to know for us is actually like that depending on the algorithm you're using, you get a certain amount of dimensions for your vector. And Spring AI uses the text embedding adder model, as you can see there. If you would upload something actually like to ChatGPT, you would get an other or two other options for this embedding model, and they might even have like more dimensions actually. The values are between -1 and 1, and that means like in this space everything gets actually like placed, and we search things which are close to like basically like the prompt, right? And that's actually like what you should see in the example. So every kind of chunk you provide gets a vector, and then it's searched basically like with the prompt in this area where the chunks are basically like related to. Okay. There are quite a lot of vector databases out there. There are many, even more like the ones we have here on the slide, and also all the big the big databases support now vector search as well, right? It's just kind of an other API with some additional information. Now within actually like Spring AI, it allows us to basically like import your data, like with a document reader. The documents might get splitted into certain chunks, and the chunks are stored afterwards here in the vector store. So by adding a dependency for a vector store, basically like it gets configured automatically, and you might have some customization done via properties, for example, if you run it on a separate server. But for example, you could use just like a Postgres vector store, basically like as a Docker container, and you could get Spring AI connected to that one. And as you can see here, basically we do the same prompts, system prompt, user prompt. We use an advisor, or like there is also slightly other approaches there, where we do the similarity search. So the chunks get added to the prompt, and then you get the answer to that, right? Good. So I'm not going to demo that. I think you will have maybe time to play around with the examples. I will have or need sometimes at the end, like for the MCP, because I find it new and also like more interesting. So that's why I'm just skipping here the demo. Now tool calling is another approach where you basically can do everything. You can actually like say, hey model, if you need data, tell me and I will provide you data from here. And then you can use that data to give me an up-to-date answer. So you can imagine something like if you say, please provide me the weather from Munich, for example, New York or Zurich, the data is not in the model, right? Because they have to be trained. And therefore, your application might to expose some endpoint saying, hey, here you can fetch up-to-date information when you need it. And then actually like you can provide me an answer. So it's kind of a ping pong game, forth and back, maybe several times until the result is generated by the large language models, right? This is just like the ping pong which is going on. Yeah. And it feels like, if you look at this like more in depth, that actually like the model is calling your code. It's not. It's just sending a text back saying, Spring AI, execute that Spring Bean for me, right, with these parameters. But it feels like the model is doing some action inside your application. So it's kind of remoting. So this is actually like how it looks like, because you can expose any kind of Spring Bean as a tool, and you would like expose those tools then actually to the model. So that means like your prompt gets enriched with a definition or with a description how your function internally can get called. And therefore you would get like an answer back, right? I'm just going to run my example here so we can have a look at this one here as well. And I'm using now the implementation with Anthropic. It's actually like the same like with OpenAI, but just like exchanged with the model underneath with the starter. So I can also demo case another one, right? So you see the Spring Bean here for the weather service, and the class which is implementing it, it just has an apply method because it's a function, right? So request response basically, some dummy implementation, and I have also some units specified, and as well some information on my request and on my response, right? And as you can see here with this JSON property description, I specify what the parameters are and how they should look like. This is basically like just for the model to know that, for example, it needs to ask for countries in the US, for example, with Fahrenheit, and with other countries, for example, for Celsius. So I had to specify that in a very clear case so that actually like the thing will return the right values, right? So the thing now, as we see here, we just like configured our tool basically. And if we run that, you will realize our Spring Bean gets executed. So Spring Boot is starting up. It's sending the whole thing actually like to the model. And now the answer is coming back, and it should tell us like what's the weather in these cities. And as you can see here, the answer is coming back, and it says like in Munich it's like Celsius, in Zurich as well, and in New York it's Fahrenheit. So, and you know that the temperature is not correct because it's just like a dummy service, of course. So tool calling is very powerful because you basically can do everything with that. You can execute basically every code. It's perfect for any kind of Java integration you want to do. Now there is a new thing actually, which is called like the model context protocol, which is a little bit hyped these days, which allows you to call even other things, right? If they expose this model context protocol. And it's something kind of this, right? Where like a salesperson just tells you, hey, this kind of pen has an MCP server, and that's like why you want it, right? Yeah. So it's a very loose coupled protocol, but it allows you, for example, to execute Python, Node, and other stuff actually. And it's becoming kind of a standard for the integration in this kind of like applications. And as you can see here, Spring AI has an integration with a Spring AI MCP client. Spring AI provides you also like a way how you could write your own MCP server if you want to, right? So some of the servers might run locally, others might run really like in the cloud, and you need to do remoting. That means also like some communication goes over HTTP, other communication goes just over the MCP protocol, which is basically like standard in, standard out communication in a very unstructured way. I have here like two examples for this, and one could be like that we say we are doing a Google search or a search engine search basically to get some answers. And this is something I want to show you here as well, right? With the MCP way, where we see in a second here that we can basically here call a node module. You see here npx, and we start basically like the node module, and we would actually like use the node module as a way to communicate to the search API and getting an answer back. I know that the thing is a little bit more complicated than what we have seen before, because we have to specify here two callbacks basically. I know it's a little bit more complicated, but I hope things get a little bit easier like soon-ish. So if you run that actually, you will realize here that the application has started, and some answer will be then provided from a search. and that means like we are just like asking questions about Spring AI in the internet basically. I think already it has no, I think it may take a while because the answer is not here yet. So the question is basically here. I'm curious. Well, anyhow, we'll leave that here, I guess, if it's not working. What I could do is I could show you the other example. I have another example like which is based on the weather data, and it does a very similar thing. It's just going to ask some weather information here, and it does actually the same. It uses like an MCP client here, and it calls a weather application, right? A weather API. And if I'm starting here my application, I'm showing you in a second that I can run a curl on the command line to execute it. I have here prototyped the whole thing, and I'm using curl to do that because I'm posting now on the endpoint my prompt. And what you saw now is, I'm just scrolling up. This is kind of like the data, which is like coming back basically like from the node application and gets added to the prompt. And then actually like the model will provide us an answer on this very special format of data, which is just like plain text from the node application, which was printed on the console, right? Good. So let's try to finish things up. Yes, model context protocol. Now these days, actually, like when you use Spring AI, you need to use patterns, and patterns might mean like that you need to have like a flow or like a workflow of things. And as you can see here, also like we do quite many things. So use patterns, you use tools. Sometimes you even need to keep like the result for the next prompt to feed in, where you need memory and other things, right? And the workflow patterns, they are just kind of evolving these days. For example, you know about like routing patterns, or if you need to like parallelize things and other stuff. And this is kind of like enterprise integration patterns, which you are going to implement. And you might even have like multiple calls than just like one, of course. It's very common that, for example, so you get some input, the router needs to decide like which the next step is to be called and what to do with that, right? And then you could even like chain different things in your workflow, basically. As you have seen, Spring AI is not providing like workflow stuff in the framework itself. It's more like a client to talk to the LLMs, but there will be in the Java space like libraries for like implementing workflows and other things as well. Okay, so we have seen today several challenges we can solve, right? For example, we have seen that we have different kinds of prompts, like even system prompts to define the overall goal. We have been talking about converters, where we have seen that like data gets mapped to the JSON format, which can be easily parsed into a Java object. We have been talking about prompt stuffing, which is used for tool calling, MCP server, RAG, and other things. We have not really touched like chat memory, because like if you need to do calls multiple times, you need to keep like the previous answer so you can feed it into the next prompt, because like the API is stateless, right? So that's why we need to have some things like chat memory implemented, right? And then actually as well, there is also like evaluating if the answer is correct, right? And also Spring AI provides you tools like evaluators to like validate if the answer is correct or just hallucinated. Great. And of course, we know that artificial intelligence or like generative AI is currently like changing the world quite a bit, and it has an impact on many different things. Yes. So that's about my presentation. And if you're interested into the slides and also the examples, just scan my QR code and you will find everything on GitHub.
Thanks a lot, Patrick. Yeah, pretty comprehensive overview of everything that might be connected in a Spring application from an AI world. Yeah, and it was really nice to see many examples and like real use cases and practical examples of this usages. And yeah, it's cool that Spring ecosystem evolves and trying to keep aligned with all this AI hype. Yeah.
I guess they have to, right? So
Yeah.
because everyone else does, so they have to do that too. And unfortunately, as you have seen, these were just like the integrations, right? Like how you would talk to a generative AI model. But the question still is like how you make sure, for example, that if a user adds part of the prompt himself and it's not sanitized, for example, how to make sure that it cannot or it's not malicious, you know? So these are still things actually like which are possible to like do within Spring AI, but you as a developer still have to think of like input output validation, this kind of things as we have done before, right? So I mean, imagine if you do RAG and they would ask like what kind of salary will Ole have, right? And the data is because it's in an Excel sheet somewhere there, you know, because you connected your SharePoint or whatever. It might be that like people could read that, and we don't want that, sure, right? So that's like where also guardrails come into place. Not only guardrails on the model, but also like guardrails like inside your application, and you have to build those things too.
Yeah, and by the way, we have one question related to your presentation. Can we have a link to the repo that was on the demo? Maybe you can post it in the chat. Yeah, right now.
We can do that, yes.
Yeah, thanks. And we have a couple of questions. Um, so the first one, yeah, also about how to keep a line with the latest trends. What needs to happen in the world for Java to become the most popular language for working with AI?
That's a good question. So I don't know. I mean, it's probably already like the most popular programming language for the big enterprise, and that means like if everyone starts adopting these kind of things, it will be there for that for sure. I think the challenge is more like what we have, and since it's such a hype in the last like 2 3 years, um, I would even say like it just needs to become normal. You know, we had like hypes in the past, like for example, NoSQL, blockchain, and stuff like that. Everything is still there, you know, but nobody talks about it anymore because we integrated that into our application, and it just became like part of our daily life. So I mean, Java and AI space and the most popular language, it doesn't matter. It's just a REST API, right? So everyone can use it. I mean, I see where the point or the question may come from. Python libraries and so on, they are maybe like more advanced at the moment than like what we have in the Java space, right?
Yeah,
That's
all
maybe the things. And also
the
like with agentic frameworks and stuff like that, and we are in the Java space just at the beginning.
mhm. Yeah, unfortunately, Python took this part of area, and now it's just a competition.
Yeah, but enterprise applications you don't want to build with Python, to be honest, right?
Yeah,
So
that's where Java rules. And thank you. And we have next question. Uh, do you think LLMs are ready to be part of production critical workflows yet?
I know that like there are out there several applications which use this kind of technology these days, of course. I guess, or like what I would say is like you can build a very fast prototype with large language models. Your management will be happy to see that you took maybe 2 days to like do something very complex, right? And they think it's like fast and cheap, right? And then actually like you will have to maintain the application probably more often because the models are changing over time. And I also like had once the issue that I did not pin a specific model with a date, with a version number, right? So they just upgraded, made the new default, and my code was not working anymore. So that means like it's probably like with other APIs, they give you some time of grace period where they say like in 3 months your model is going away, and you have to change it. So that means like you still need to maintain your application, adjust basically the thing, except if you run the models like in-house, right? Then it's different. And we also, I mean, I just read yesterday some stuff that like all the AI providers, the public ones, they're kind of selling your data. Maybe you don't want that, right? They're not as well transparent as we like. It's also to be more independent. I mean, we love to maybe also have like providers like in Europe doing these things and not only like the big companies in the US. So yes, I mean there are applications out there. Often they are chatbots. I know some applications which do more nice things, to be honest. But I think you would have to tame your application or your large language model, provide like good guidelines, be very precise with the task which needs to be executed because of hallucination and other things. And it's not so easy to make it really, really good, you know? So this is still something we need to find out. And then actually like the other thing, as I said before, input validation, output validation, guardrail stuff. So yeah, still
Yeah,
like
thanks.
good work needs to be done there, like as we should have done like all the time before, right? Yeah,
Yeah, thanks for your thoughts and input. Yeah, it should not be just as it's called right now, wipe coding, right? And just
definitely
building
not.
random stuff without
Yeah.
understanding it. Yeah, we still should take care of that. Um, and the last one, the last question. Uh, how well does Spring AI handle context management or history across chat sessions?
That's a very good question because I did not show it before. The in the example, it should be implemented as chat memory. So this is kind of like an API they provide additionally, where you could actually like keep the conversation from the previous API call and add it basically like to the next API call. So this chat memory abstraction Spring provides gives you also like the integration, for example, that you can store it in a database. Because the obvious simple one is basically like in memory, but if your application is deployed across multiple nodes in the cloud, then you need kind of like have a shared space, right? And they do that. So they provide several database integrations. Otherwise, you just do your own, right? And this is like how you do this chat memory. And I find it very interesting when I usually like work with developers and we prototype some stuff. They think like what they see in ChatGPT is like what they would have if they would do the API calls, right? But ChatGPT is kind of like the application which does like all these funny things like chat memory. It knows your user profile. It knows your previous
Also client, yeah.
conversation stuff and so on. It's the client on top, right? On top of the API. And behind that, when you ask to like generate an image, it's basically it's just a client calling then that model which generates the image and stuff like that. Yeah, exactly.
Hmm. And what do you think might be the future of this Spring AI project? What might be new, or will it be more lightweight, keep more lightweight as a client, or become really orchestration tool of different?
Well, I'm not sure like what the future will bring. I just know that like there was general availability in May, end of May this year,
Mhm.
and that means like about a month ago. So that means like the Spring team usually supports this stuff like for 7 years. So like it became now like base infrastructure. The other thing
Okay.
is actually like that the inventor of Spring, Rod Johnson, came up with a library. It's called Embubble. So it's basically something which builds on top of Spring AI, which should give you some things like agentic workflows and things like that. So I think, or it looks like at the moment, it could be that Spring AI still stays like the basic infrastructure level, and then other library providers will do something on top of it, so that you have like in Python, like Crew or other agentic libraries which help you to do the orchestration, to the workflow and stuff like that. Yeah. So we see at the moment some things going on there in the Java space, and
Mhm.
it looks like Spring is at the moment just like basic infrastructure.
Got it. Yeah, thank you. Really interesting topic, a great presentation from you, many examples. Personally, wanted to try everything by my own later. So thanks again participating in our event. Yeah, it was a pleasure to have you in our event. Thank you.
Thank you for having me. Take
And
care
have
and
a nice
enjoy
day.
enjoy the day.
Yeah, you too. Bye.
Bye.